So I'm Jessica Seddon. I am a senior fellow at the Yale Jackson School of Global Affairs, and I am very happy to have been invited to chair the last panel of the day, which is always kind of a daunting thing on a day that also starts at 8:30 and involves as many papers and difficult topics and thoughts and possibilities as these sessions have. I'm also the Jessica who was invoked in the beginning of the session as saying that the climate emergency is here now. I'm not going to revise that. I'm just going to add a little addendum. I think what's happening when you start to look at some of the growing pile of scientific evidence is that we have an unfolding, likely accelerating set of environmental changes that include but go way beyond temperature, rainfall, and sea level rise. These are changes that we have an increasingly well-grounded, bounded understanding of. We have an understanding of some of the nonlinearities and also a great sense of what we don't understand about how those are going to affect the infrastructure, services, economic setup that we have. Ecuador right now is having rolling blackouts. It's a highly hydroelectric dependent economy. And El Nino has not been so great for hydroelectricity. That's a little bit out of bounds from what's happened historically. These are the kinds of things that we can, from the science side, anticipate. At the same time, on the human side, it's pretty clear that we're a species that is not passive, that is entirely capable of responding to very significant changes, both local, regional, and global. Sometimes we're self-interested, often we're venal. We suffer from moral hazard, and I think some of the papers have highlighted frictions that are deeply social in how we adapt to these changes. But we know these things, these two sides, these two streams of knowledge from very large intellectual enterprises, both on the climate science and climate impacts modeling on the one side, and then also from economics and more broadly social science, understanding of microfoundations. I think we have an enormous amount of knowledge about the first principles, the dynamics of environmental change on the one side, the dynamics of human responses on the other. Our challenge going ahead is how do we put these two streams together more effectively? How do we better combine this understanding of the micro to maybe meso foundations to build an understanding and a sense of ability to make some of the trade-offs that we need to make now, use of scarce resources, now versus later, this versus that, here versus there. What are some of the narratives that balance urgency, but also recognize agency and adaptation in anticipating cost? Most importantly, and for me, what are some of the ways that a combined stream of understanding the climate dynamics very, very well at high resolution and the human social dynamics at higher resolution, what does that say? What does that tell us about interventions, policy instruments, investments in information, investments in credible information, the kinds of institutions we might need to create social tipping points to respond to the environmental and climate tipping points that are increasingly, unfortunately, looking more probable. I think with that, I mean, that enterprise is both an intellectual one, it's a research agenda, but it's also in some ways an institutional one in how we organize interdisciplinary conversations, interdisciplinary research agendas, and spaces for framing the questions, setting agendas, talking about how we represent humans in climate models and climate in human models. And for that, we have the next hour to figure all that stuff out. But luckily, we have an excellent panel. I'll introduce them in a second and ask them to come up for some opening remarks. But I just wanted to also say one other thing, just to set expectations about this is also a bit of a tortured panel. We have an hour and 10 minutes left, hour and 15 minutes. And what I've asked the panelists to do in kind of design thinking mode is give opening remarks on what they, in their work experience, what they, in their their research and their practice as policymakers and as people who have been engaging in interdisciplinary conversations, what they see as gaps in combining the human side and the climate side. And then we'll have a discussion of some of those gaps. Then we'll come back for 5 relatively longer remarks from each of the panelists on what can we do to resolve some of these gaps. Hopefully, looking at the problem first, then responding with solutions will lead us to some ideas that wouldn't have occurred to the 4 panelists just coming in fresh. So we're hoping to have that kind of discussion, and at the end, leave some time for Q&A. So I want to introduce the panel first, and I'll call them up one by one, but I'm going to introduce everybody now so you can see where people, or anticipate maybe where people are coming from. Everybody's bios are on the conference program, but our first speaker will be Tony Smith, who is a professor of economics and chair of the department at Yale. His research is mostly looking at global economy climate models with high geographic resolution, or that's his most recent focus. So I'm anticipating that he'll come with perspectives from building those. Our second speaker will be Regina Rodrigues, who is a professor of physical oceanography and climate at the University of Santa Catarina, Federal University of Santa Catarina in Brazil. She co-chairs the World Climate Research Program Atlantic Region Panel and Marine Heat Waves Research Focus. She's also a co-principal investigator of My Climate Risk, which she'll tell you a bit more about. Third speaker is Piers Forster, who's professor of climate physics and the founding director of the Priestley International Center for Climate at University of Leeds. He's also the interim chair for the UK Climate Change Committee. He's known for his work on radiative forcing, climate sensitivity, and has been a lead or a contributing lead author for the 4th, 5th, and 6th IPCC reports, as well as the 2018 special warming report on special report on global warming of 1.5 degrees Celsius. So, and our 4th speaker, Tejal Kanitkar, who gets the prize for being up the latest of all of us because it's 3:30 a.m. where she is now, will be coming in by Zoom, is an associate professor at the National Institute of Advanced Studies in Bangalore, India, also an IPCC author, and her work has been looking at equity within the general enterprise of climate modeling. So I think we've got a great panel coming from different perspectives. Hopefully, between all of us, we can describe some of the gaps and solve some of them. With further ado, I'll turn it over to Tony for 5-minute opening remarks. Thanks.
Great. Thanks a lot for including me in this workshop today and this conference. It's been a fascinating, long but fascinating and also stimulating day. I've quite enjoyed it. So I didn't want to risk not having slides, so I have 1 slide with words and 2 pictures. But are those going to? Can I just go ahead?
The clicker should work.
Right. Okay. Got it.
They should all be lined up.
Yep. And I'll have the same problem everyone else is having. Okay.
Oh, no, you're going backwards.
Sorry. Yeah. There we go. All right. There I am. All right. So, so this is my 1 slide with words. So what I've been working on, I'm a macroeconomist by training, and I've worked on heterogeneous agent models of the macroeconomy with heterogeneity across households, and since parlayed that those methodological skills into building or attempting to build high-resolution integrated assessment models. So the idea here is to build computational laboratories for evaluating the effects of climate change at a high degree of resolution geographically. And in particular, what I've been working on most recently is to merge Earth system models with dynamic general equilibrium economic models to incorporate, in particular, weather and extreme events, as well as climate. So it's called two-way coupling in the literature. I think I'm partly on this panel, too, because I am working with 2 climate scientists on this coupling that we're working on. Trudy Sirelmo used to be here at Yale, and that's where I met her, and now she's in Norway, and it turns out she's a co-author with Piers Forster on part of the IPCC report I just learned today, and then one of her students. So we're working together trying to integrate these 2 models. And this next point is a little bit a point more for climate scientists, but there's more economists here and fewer climate scientists maybe, but we're trying to build a fully articulated, what we call a structural model that spells out the behavior of the climate system and how it interacts with the economy and how agents behave and how they respond to various policies that might be designed to address climate change. So we can look at quantitatively the effects of counterfactual policies and ask questions like, how do resources move across space? That's spatial adaptation seems critical here. Who gains and who loses? And once you have a model like this, you can then ask questions about doing a detailed quantitative analysis of international climate agreements or international sharing of climate risk. So I'll just show my one picture. This is just an example. This actually looks a lot like pictures that we've seen today, although it's coming from a very different set of methodologies and tools without going into details. This is showing a counterfactual experiment in a model calibrated to the global economy, showing who gains and who loses from a uniform tax on carbon. These are percentages of consumption per year. So basically, places that are already hot are losing. Places that are already hot, like a carbon tax, they want to slow down warming and they're gaining. So that's just sub-Saharan Africa. That's Saharan Africa. Russia is actually losing from a carbon tax because they're cold and would like to warm a bit. So we've actually seen this picture several times today, I think. Another thing we can do is look at inequality, say. So we have this, the model is actually broken into 19,000 little regions. So each, I'm experiencing what other people have experienced. So each agent is a region. Each agent is a little region, so 19,000 of these, and interact them through markets, they make consumption saving decisions, energy decisions, they respond to tax policy, they interact through capital markets, and they interact through the global climate system. All right, so once we have this model, then I can ask, how will inequality change over time? So this is showing this is GDP per capita by country, not region, aggregated to countries. You can see the 90-10 percentiles in measure of inequality. It starts at 30 and according to my model, increases to around 46. That's the top line. The second line shows what happens in an optimal tax, and this model actually doesn't change things very much. But the point is that you can run this counterfactual experiment. All right, so what I would say, getting to my last, that's sort of where I'm coming in and what I'm doing. The challenges that I face is working across disciplines. It's just getting that conversation going, understanding how an Earth system model runs, and then teaching the climate scientists how my economic model runs and why I need to think about forward-looking behavior, say. And I think the more we can get people together, like in rooms like this, and get interaction going, the more we can build more plausible and interesting models. So I would say we need micro and macroeconomists. We need climate scientists. We need ecologists, geographers. And a number of the papers today, like Valerie's paper and then the paper on Jakarta that Alan just gave, papers this morning, all those papers can maybe inform the macro model that I'm building. And then next, what I think we really need in this space is powerful computing resources and technical expertise on numerical analysis and coding to solve these models. All right, so I think I'm done. I will stop there. All right, it's my 5 minutes. Okay.
We have, in the order, sorry, I have to come to the mic. In the order dictated by these slides, deity, we have Regina is our next speaker. Also, just as a background for these opening remarks, the ask was, where do you come from in terms of your past research, and what are the types of problems that you see? So hopefully we'll get some commonalities and some convergences. Over to you.
Hi. Thank you. I would like to thank you, Jessica, for inviting me. And as she said, I'm a climate scientist from Brazil. And I work particularly with climate variability and extremes in South America. A region has been exposed to many hazards lately, as you can see, as you can know. And I realized that most of the climate information generated by scientists wasn't reaching the people that most need. Society. This is a perspective from obviously climate scientists and climate information, mainly in the global south. And in order to reduce the vulnerability, increase the resilience. Jessica asked us to say what we think that is the big gaps, and in our case, for decades, there has been a call for usable or actionable climate information, yet despite this awareness and global effort, it's widely accepted that there is a significant gap between the production and the use of climate information. And I argue that the gap results in part from us, climate scientists, focus on better data and models, rather than better decision-making. So, it's going really fast, this. Okay, well, we generally use a top-down as a climate scientist approach that adopts a disciplinary-based measure of scientific quality. The problem is that even if user-informed, such a top-down approach is inevitably driven by us climate scientists themselves, and that does violate the core principle of co-production of this climate information. So, sorry. So our traditional, that's where I wanted to be. So our traditional ways of producing aggregate climate information can leave climate scientists empty-handed for many regions of the world, particularly in the global south. For example, this figure from the last IPCC report aggregated all the information from data and models described in literature to identify if there has been changes in precipitation leading to agriculture or ecological drought, but they did this exercise for other aspects. And you can see the regions for which there is limited data or literature on past changes are showing gray, with low agreement on the type of change showing hatching, and all with low confidence in the human contribution to those changes due to limited evidence is showing open stapling. And we can see that vast areas of the global map are still gray, hatched, or with open stapling. This is due to the limited long-term data records or poor representation of climate models of the relevant physical processes behind extreme events, and the ambiguous model prediction of the forced response to climate change for those regions, mainly in the global south again. Yet there can be a wealth of local climate knowledge if you actually look at the chapter 10, and that is ignored when we try to do disaggregation. So my last thing that I want to say that is then climate change science, as its current practice, tends to frame the scientific questions as singular definitive ones. It does this by focus on projections from climate models and emphasizing where there is consensus among them, acknowledging uncertainty but not actually exploring it. The focus of a singular definitive problem is also expressed in a still common practice across most published climate change science to interpret statistical significance in a dichotomous true-false manner and avoid the articulation of a multiple possible hypothesis which would allow a plural conditional framing of uncertainty.
Okay, well, it's been a very interesting day today. So I'll tell you where I come from. So I'm a climate scientist, and I spent a long time just trying to make the best possible projections of the average surface temperature. And if you look at the IPCC report from last time, we were able to make a significant change from what we've done before. We have this simple physical climate model emulator that we are able to calibrate with the more sophisticated ones, and in particular for the IPCC report, we were also able to calibrate it to the observations and be able to calibrate it with good physical understanding from the different chapters of the IPCC report. And we were able to put the lines of evidence together to be able to really constrain our surface temperature projection for the first time. And by doing this, we were able to exclude some possible very high surface temperature projections. So for your economists doing all your kind of risk analyses, that should be a fantastic thing to be able to include. And it is really encouraging that this model has been taken up by your community. I've heard that Bill Nordhaus has now included in his price model. I mean, I'm sure he's a fantastic economist, but he's not a good climate modeler. And the actual climate modeling component was a bit, well, I'm not going to say anything. I mean, he's a great guy. So, but anyway, so he has replaced it by the one that we have, which is great. And this is the one that would also the United States government do use to calculate their social cost of carbon with. So that's fantastic. But and I absolutely appreciate the citations, but I would appreciate far more than that the conversations. And it was interesting that was done without talking to us. So and it's only people like us that really comprehend, understand all the assumptions that that actually go into the calculations. And I think far more than just the conversations as well, I'd appreciate the change as well. That of course the projections depend on the thing that you guys know, like the GDP and the population changes and all the other things. And it would be good to be able to work out the way they interact by the conversations. And as Jessica said at the end of her introduction, I have recently become a politician. And it's very interesting that you can give governments the very best evidence packaged very well, but they don't necessarily do anything with that. And and we haven't got a lot of time. But I think we get to act together as a community where we sort of can do things. So the Inflation Reduction Act was a good opportunity example where there are these instances, and I do now know in my new position that I suddenly get a telephone call from number 10 and they say, please can you think of something to do, you know? So there are the opportunities. And I think if we as a community have that sense of urgency to affect change, I think we can try and do things a bit differently.
So while we're switching the screen over to our fourth panelist, Tejal Kanitkar, who's joining us from Bangalore, I just wanted to highlight one thing that Piers mentioned, which is we're the ones who know the assumptions underneath this. And I think that may be one of the focal points for the kinds of conversations and the conversation space that we can have. Let me know when you're up there, Tejal, for opening remarks.
Thank you, Jessica, and it's been great listening to all the interventions throughout the day. Well, it's been throughout the night for me, but since there's very little time, let me jump right into it. I'm going to speak about the macro models, especially the integrated assessment models, or the IAMs, some of the first of which, in fact, came from the Department of Economics at Yale. Of course, I'm very grateful to Piers for being sufficiently provocative so that I may sound less so. The IAMs have become the dominant modeling tool for projecting socioeconomic and related energy use trends into the future. The sixth assessment report of the IPCC depends quite heavily on these IAMs. While there are a range of discussions in the IPCC reports about, a lot of other things, the summary for the global model scenarios from the IAMs disproportionately dominate the summary for policymakers, which are then further even more disproportionately picked up by the media and then even more distilled and used without the accompanying context very often in COP decisions. Right? So both COP26 and COP27, for example, quote the number 43% reductions in GHG emissions, which corresponds to the median of all global scenarios assessed by the IPCC for the 1.5 degrees Celsius target. So it's become a prescription for policy, and so it becomes important to analyze this. My work focuses on questions of equity and justice in modeling, burden sharing models, as well as other kinds of models. I'm not going to go into the details of what the IAMs are. I'm speaking to an audience that is probably more aware of what these do than I am. But what we have essentially is a combination of macroeconomic models that are based on neoclassical frameworks, energy models that focus on minimization of costs of abatement, vegetation models with earth system feedbacks, coupled with scenario frameworks that are essentially socioeconomic storylines for the future. So you have, will there be sustainable development? Will there be fossil fuel dependence? Will there be cooperation or regional rivalry? These are the kinds of storylines that are projected into the future. But I think one of the first issues is that the world in these models is divided by geographical regions. And this is what we saw throughout the day as well when modeling results were presented, which itself is a problem. I think Regina spoke a little bit about the problem of risks and how they are assessed when this happens. But such a distribution doesn't tell us about differentiated levels of development, production, consumption, etc. When there is an economic differentiation is only for the OECD. So it's only the OECD that are economies. The rest of us are essentially just geographies. And so that is one issue. The second is, of course, that irrespective of storylines that you construct, the macroeconomic models that essentially pursue Pareto optimality and, most of the macroeconomic models follow the structure, and the Negishi frameworks that are used freeze income inequalities at current levels, not allowing any more convergence than is considered reasonable based on historical trends. So you have inequalities these are results of the IPCC scenarios that we have assessed, about 556 scenarios corresponding to the 1.5 and 2 degrees Celsius temperature targets. So you have inequalities that persist across regions, even by 2050. These GDP and consumption figures are, of course, linked quite significantly with energy. And so you have energy poverty and energy inequalities that persist also throughout. And this is tied to how energy demand and supply are modeled and coupled with the macroeconomic models. The objective is to minimize the cost of mitigation. So the solution is to find optimality in terms that are both spatially and temporally cheaper. So, if it is cheaper to reduce emissions through agriculture and forestry in the developing countries as compared to, say, the reduction of oil, gas, and coal use in developed countries, that will be the solution. And so you have extreme levels of energy inequality persisting across model scenarios even in the future. And the models therefore then end up projecting much higher levels of mitigation burdens, both in the short and the long term, on developing countries. On an average, for example, sub-Saharan Africa is expected to reduce emissions by 80% in this decade across the scenarios, whereas the reductions are about 50% for Europe and North America, in line with the NDCs of these countries. Right. The models also project large amounts of carbon dioxide removal across models. Most of this is coming from the global south through energy, the diversion of land from food crops to energy crops, increasing the risk of hunger across the regions. And so therefore, the current trend of decreasing risk of hunger is in fact reversed in some of the more extreme scenarios that are assessed by the IPCC in the future. So the questions of equity, questions of dealing with questions of vulnerability and risk, which are unequally distributed today and remain unequally distributed even in the future, are not addressed in the current modeling framework. The global south is denied the means to build resilience that we've been speaking about throughout the day. And this is a major gap. But there are ways to address this, and maybe we'll come back to this later. So I'll stop here. Thank you.
I think the opening remarks have really raised two classes of problems. One is in some ways you could call it the internal discussion between groups of experts. So to what extent are the findings and the assumptions and not just the headline, but also the guts of the different models about how humans behave? What are the embedded pieces in the story? What are the assumptions that are made in order to deliver an estimate of surface temperature? What are the obstacles to having a conversation about those assumptions and whether or not those are reasonable and whether the inferences about, say, human responses to the average surface temperature are really capturing human responses to the larger set of things that are embedded in the model. So one is the conversation between experts. The other is the fact that these conversations and these models and these representations also shape social conversations at multiple levels. So there's the issue that Tejal referred to, and I think what Piers referred to is, and with the use of the models in informing kind of macro decisions, and the issue that Regina pointed out, which is in some ways the use of risk information in informing and in dialogue at the community level. Both of these are important. Both of these information flows are important because obviously the link between what you understand of environmental change shapes your response, shapes the environmental change and forward. So you can't really see these as two isolated issues. I think just for the purpose of discussion, if we could tackle these two a little bit distinctly, because otherwise we end up with a big sort of ball of things. I guess the first question is, Tony, you mentioned having the conversation and the importance of having the conversations, but in each of your professional lives, where have you found easy ways to have those conversations? Have you been professionally rewarded for having those conversations? And are there ways to make it easier and more rewarding to do that? If you haven't found that already, what would it take to make it a more normal part? And we can start with you, Tony, and work through the panel.
Okay, I think I used that same phrase in my slides, that we want to reward this kind of interaction. I think in general, it's quite difficult to reward that interaction. We're kind of siloed in departments with certain standards for tenure, and especially for younger people, it might be a little bit risky to try to go work with some climate scientists on a risky project about building a big climate model that incorporates Earth system richness. So I don't have a particular answer for how to address that. I think somehow that we need to reward people doing this kind of work. And very often, even within economics, you'll be across two subfields of economics. Sometimes it can be difficult because you're talking to two different audiences sometimes. So I don't have a particular answer to that. Somehow we need to recognize in departments or in universities that this kind of work across disciplines is super important. And it may not satisfy everyone in all the camps, but it's a new product that no one's ever seen before, and it offers something special. So it's a question of what journals you publish in, and there's a whole set of issues there. And in terms of getting conversations started, I think that's hard too, because we just don't see each other. I think it was Ken Gillingham, who was here earlier at the School of the Environment, organized a conference on getting together macroeconomists and economists and climate scientists at up in the School of the Environment a few years ago, where I started talking to climate scientists and realizing that I was in over my head a little bit on my own. So I needed to learn from them. That's how I met Trudy, and then one thing led to another. But it takes a while to learn how to be comfortable with people and how to trust people and a cooperation. So we had to nurture that relationship for a while, but now it's up and running.
So just one question. I mean, other than that, when you look around at other universities or other academic spaces, do you see an example of something small that could be scaled up? Are there lighthouses that we could work from?
Offhand, I don't really so much, to be honest. You're looking for an example of maybe two very different disciplines, someone's working across them and being successful. I'm sure there are, but I can't think of any offhand. I know within economics, I think it's a bit of an issue, actually, to be honest.
Well, we can take that as a challenge for Yale Planetary Solutions. We can take that as a challenge for HEC.
I'm not trying to be, maybe I'm too pessimistic. Others could disagree with me, but that's kind of my take on it.
Thank you. And Regina, I think coming from a different discipline, what has been your experience with building projects like My Climate Risk or some of these more interactive, speaking with decision makers kinds of projects? And I'll pass you this mic.
I think you respond to your previous question a little bit. For us climate scientists, the problem is that we are rewarded by papers, and it's a quantification and not policies. I think we could be, as a scientist, also be rewarded when we, in our career, for tenure, and we focus too much in the number of papers that we publish, and not to actually results of the science that could be used for policy purpose. And it's a challenge to publish papers in multidisciplinary papers, journals that actually accept when you're transversal. This is also a challenge. And for us, the point that I want to make is that we generally, in our style, we come up with ideas or things that we think that needs to be studied and understand, and we generated this climate information. And then when you go to the communities, it's not exactly what they need. And so now in a World Climate Research Program, we have this kind of a new activity that we go to the communities, and we needed to talk to them and then create the information, not try to adjust that information that we already have in a format that we already have, and then try to kind of push it down. So then it's a kind of a bottom-up approach. And that's what we are trying to do, and have this conversation with the communities from the beginning and make them to be able to then use that information and even create the information that they need and be self-sustained. And so maybe that's it.
But I think I just want to highlight one thing that Regina pointed out in the supply and demand of different scales of integrated models, or different scales of climate, even just climate impact and risk models. In some ways, the whole enterprise of integrated assessment models came out of an expressed demand for an ability to make a certain kind of decision. And I think there is a broader question when we're thinking of what is the agenda to build humans and climate, climate and humans. We need to acknowledge a broader set of demanders and needs that may not be as visible as macroeconomic, national, or state policy making. And that's a whole other challenge. And so just to flag that this research and institutional agenda for combining the two has multiple sub-areas depending on needs that can be really quite different, not to complicate things. Back to you, Piers, on have you been rewarded for having the conversation?
Yes. Well, I absolutely kind of have done. Probably the best example is the IPCC report on kind of 1.5 degrees. I mean, the IPCC terribly institutionalized and kind of siloed, but just for this report on 1.5 degrees, everything changed. When we were set a tight timeline and we had to get all the disciplines together, from the engineers with the kind of solutions to the energy experts to the kind of climate scientists to the economic expert to the kind of political experts. We had to get them all together, and we had to come up with a kind of report, and it was incredibly successful. You know, it sort of started every country trying to get these net zero targets, and that kind of began my job in politics, but it also inspired me to set up an interdisciplinary research centre as well, where we try and bring different disciplines together. And what I find from doing that it doesn't work for the old professors, but it certainly works for the younger generation. They don't particularly care if they're kind of climate scientist or an economist. They sort of just want to change the world, and they sort of want to kind of cherry pick and be taught the expertise to change the world. And I sort of think time is accelerating for all of us too. Like, we have artificial intelligence on the kind of horizon, and that can really change our kind of disciplines. So I just think to be on the kind of cutting edge, we sort of ought to do these kind of cool things are fun.
There's the ought to. I think the question is how to set up some of the incentives to do it more often. I mean, I think who you're seeing on this panel here are all people who have taken the trouble to do this. And I just want to sort of summarize where we are now before turning it over to Tejal, which is in some ways we have, okay, it's hard, there are frictions, just like there are with adaptation, but in some ways, if we can, you know, there's a willingness, there's a goodwill, there's potentially a younger scientists who want to change the world, but then there's also, where there's a pull, there's a response, and that research then generates or potentially could start a positive cycle. So that leads us, I think, into a second set of questions that we'll come to, and how do we articulate that pull and respond to it effectively, knowing that there are frictions for doing so in the way that sciences are structured. I want to turn it back to you, Tejal, for just your thoughts on rewards and how to increase them for the kind of work that excavates the assumptions that you've been looking at. And yeah, your thoughts on what might make it easier to reduce the frictions.
Yeah, I think, I mean, I agree with Piers to the extent that, you know, there is definitely a difference in how, you know, younger people now, my students, for example, I have a mix of social scientists and engineers as students, and they work together and collaborate and produce, you know, work together, because the environment in which we do science has changed to a certain extent, and the problem of climate change, I think everybody has recognized, doesn't respect disciplinary boundaries. You need to speak across disciplines. But I think another issue is that, while IPCC is not just siloed in terms of disciplines, but also in terms of where authors come from. I mean, especially if you look at the IIMs and the scenario modeling, it's largely based in the global north. And that's if you talk about global climate policy, that's a huge gap, because you have 82% of the global population that's very, very invested in climate policy making and negotiations, but plays very little role in producing and assessing the science, be it the natural science or the physical science or the social science that goes into the IPCC reports. And that perhaps needs to change also as conversations are changing with the newer generations, maybe doing things differently.
So just one, I think that raises a really, that is a good segue into a really important second set of questions. Sorry, I'm human, so I can't speak to you and have Tejal's face behind me, which is why I have this awkward pose here. But I think that segues into the second set of questions, which is really, how do we create and articulate not only a demand for the kind of integrated research to inform questions that are very present here and now, but also some degree of discernment and willingness for not everybody, but at least somebody to look into the assumptions in ever more complicated models, either climate or human or both, and to highlight the problematic ones, because I think that articulation of demand as well as building of discernment are two critical features of creating an environment that might be sufficient to push us over the frictions to generating a useful set of knowledge. Tejal, do you have any ideas on that? What might just increase the discernment and draw more attention to these assumptions, these and other assumptions?
I don't know, that's a bit of a difficult question, in the sense that a lot of, it depends on what assumptions we're talking about. For example, in the climate science domain, there might be, you deal with a lot of known unknowns and a lot of unknown unknowns. And as our understanding of the natural world expands, our computational capacities increase, we perhaps are able to answer questions and look at assumptions more closely. But in the social sciences, and especially when you couple these with the natural sciences, as happens in the modeling domain, it's a lot of the frictions are ideological, perhaps, and also based on perspectives in terms of where we come from and the kind of questions that we're interested in. Are those in the modeling in the global north interested in answering questions of equity, or is it something that only researchers in the global south will raise? And if they raise, will there be capacity to respond to that demand in the global south? So will we be able to build models, for example, that don't trade off equity against efficiency, right? They don't start with the objective function of minimizing cost, but perhaps start with the objective function of maximizing resilience. So do we have the capacity to respond to that demand, even though there is a political demand to address those kinds of questions? So that, I think, still remains open. So it's not something that you can answer perhaps in a uniform fashion across domains, in my opinion.
So I want to ask you next, Regina, for your thoughts. I mean, you showed a nice graph that's clearly in the public domain, and it's in the IPCC report, of what level of certainty we have about relevant climatic conditions in different areas of the world, and made the point that underneath some of the more general predictions and statements, there is a huge geographic variation in the origins of that information. That's something that's out there, but it's not widely known or recognized. Do you see a space or a way to create more discernment and demand for evening that out?
Yes. So what we are trying to develop in the World Climate Research Program now is hubs, local hubs, and we can help them to develop their information that is available. I'll give an example because otherwise, so the Met Office of Brazil doesn't do a good job of deliver a seasonal prediction, which is really important for agriculture, energy. Brazil is hydroelectric, 65%, so that's really important for energy purpose too. And I live in a southern Brazil, and certainly the predictions from the Met Office for the whole Brazil and in southern Brazil doesn't work. The global predictions from, other places also doesn't work. You need a lot of investment in capacity building and money to run these models, which is not available. So what we do is we get the local state government, a small group of meteorologists, and we help them develop simple tools that they can get this information from, say, emergency response. My state has a lot of extreme events. So, and then we are doing this. We're getting these hubs around the world, particularly in the global south, and help them with really simple tools that doesn't require too much money. We have this information already, enough information available to make them more resilient. And then they learn and they can be self-sufficient to start to kind of producing that climate information that they need for, say, whatever, emergency response for extreme events or, I don't know, energy, etc. policies.
Steal this back for 1 second. So I want to leave time for, I'm going to come back. I want to leave time for questions from the room and from Zoom. But just to quickly summarize and take a poll of the panelists on whether we're on the right track in terms of an agenda for being able to do this better. If there are 2 buckets, one is something to do with generating greater and more influential pull for effective integration, recognizing that that pull must be, or that agenda setting must be more equitable than it has been in the past and may ask different questions, may pose different challenges for integrated models. So some intervention on the pull side, hoping that the pull helps grow efforts to overcome frictions, inspires early career researchers, and perhaps highlights some of the, we don't have a good answer yet on what would remove the frictions for bringing the 2 groups together. But there's a pull side and there's a, that is necessary for unlocking the friction side that we don't have a good bet for. Is that a reasonable 2 buckets, or is there a third class of to-do agenda that I'm missing?
I do think that's fine, Jessica.
Okay.
So that.
Anybody have anything to add? Tejal, Tony, you looked like you were about to add on this.
I guess I'm not sure, Tali, what you mean by a pull side. You mean a demand for better integrated assessment models that can address, say, distributional issues around the world or inequality. So you're looking for some mechanism that would lead more people to feel like that's a good endeavor to engage in their research. Is that what you're asking?
Yeah, I mean, a pull or a voice, an ask.
Yeah.
But I should interpret that as really principally coming from the kind of demand. There is such a demand by society, kind of really to give them actionable answers that work for different countries, and that is the big kind of pull as far as I'm concerned. And I mean, and I think that pull is really there and is really kind of working. It's very effective, and I think what Tejal has been saying is absolutely correct, that I would really love to see India produce its own IAM, and it has the capacity to do that. And I think that really where we have to make sure we're challenged by different expertise, and that experts in India have their own expertise that they can bring to it, and we have to be accepting of their expertise, just like the expertise of indigenous communities in kind of Brazil that have their own expertise, and we have to be open to that and inclusive to that. Just to myself, just have to be inclusive to the economists out there that perhaps feel a bit excluded by this conversation.
So I'm just going to, including, excluding, I think that there's, there's clearly a very large agenda to both be articulated in terms of what are the what are the questions that require an understanding of both the human and social dynamics in order to make well. And then there's an enormous set of tasks on reducing the frictions. I think the good news is that there are a number of people who are already involved in that, who are doing it because they see the need, and we are in some ways fumbling toward doing that better and better. I want to leave the last 15 minutes for questions from the audience, because I'm seeing a bunch of hands and twisting. Kostas.
Thank you. Super rich climate models, and we have less rich economic models. And I mean, it is a question of cost benefit. Let me try. There's a question of cost benefit. Where do you start, right? So Tony has like already a rich model, but what is the elements that you want to put first? A few elements like heterogeneous agents, or what are more capital choices or something, many sectors? Where do you start?
I think, at least in the economics literature and the general equilibrium macro literature, I think what's been missing, although it's a growing field now, is looking at heterogeneity of the impacts of climate change and climate policy around the world, getting at questions of inequality. I think that's just been missing. But I think we're starting to build models that economists all certainly are buying into to address those questions. And I think one thing that's missing big time still, that's why I'm working on it, so I'm tooting my own horn here, but I think we pretty much just are putting an average temperature, no weather, and just viewing that as the main variable, which it probably is. But I think we should be looking at extreme weather events as well, putting in weather as well as climate into the models, and recognizing that weather can impact locally. Maybe not, it doesn't, we don't get a hurricane across the whole US, we get a hurricane locally. So we need to model those somewhat more local impacts and then study how we can share those risks across governments or countries. So I think it's quite important to bring in inequality, that this heterogeneity impacts. I think that's pretty well established by now. When I first did my first version of the model, I was like, this is crazy how it's coming out so heterogeneous. And I think weather is just super important. There's some work, I think, Rossi Hansberg and Bilal, the paper that Sam mentioned earlier, is doing some of that, but we need to do much more of that, I would think. And that requires bringing in the richness of Earth system models, or maybe using a very good emulator that will let us look at regional weather impacts.
So I'm not sure if what I'm about to say is a question or a comment, but I felt like this was so pessimistic compared to, well, having spent nearly 2 years in the White House Science Office and looking at how science was coming into policy. I came away from that experience being completely awed, at least how much science we were trying to gobble up and organize and repackage, and how important it was. And what I took away was that there's a missing link in the feedback scientists get when that happens. And I think this is part of the challenge, I think we as a scientific community have to also think about like what feedbacks are we actually expecting? Because it seemed to me when I was at the White House, like the most important work was like, you don't cite it, you let the secretary take credit for it. Or you said, you let somebody else take credit. It's plagiarism was actually like, I don't want to accuse the White House of plagiarism, but like, just poaching stuff was like, that's the really important stuff. When you start citing, it's less important. And so I'm wondering just what do we expect as a scientific community in a world where we're super unique as researchers? Like people read our papers, they cite them. This is how we evaluate stuff. We look at like exactly we count. But even if you go to like a corporate world, nobody knows exactly anybody's individual impact. And so how we're operating with a world in policy that like individual impacts aren't tracked. And so what are our expectations for being able to think about how our science is responsive to policy and how we understand that and how we get those signals back?
Does anyone have any thoughts on that? I think it's an excellent question and observation.
And I would say that I've had exactly the same experience that, I do see lots of examples in my career where it's really worked very well. And perhaps we should take optimism from that though. But I've also, through the IPCC, I worked in other countries a lot. And I think in a lot of different countries, they don't have the same capacity there. And so perhaps that is really something that Tejal and Regina can comment on. You said you came from a particularly bad part of Brazil where they completely ignored you.
Well, let me just get my thoughts here. The thing is that I think we have a lot of information for mitigation purpose. What makes me frustrated is that we know that what we have to do, but politically in the high levels we are not having the engagement. This is very upsetting, and I'm not optimistic when I look at the mitigation aspect, and I know that we already have enough information that we needed to, get to net zero, etc. But what gives me hope is when I look at the bottom-up approach that I say, which is more this grassroots process of empower the local community to make sense. Then we can build trust. We can use that conversation in a local level, But it's not like for scientists, that's sometimes it's not so glorious as the high level, Scientists want to get up there, they want to just talk to, and make difference with politics and in a high level. And it's not like, but I see hope in grassroots science developing this. So I don't know if I passed this pessimistic, but when I think about the bottom-up approach in terms of climate science with communities, then I think we will change, because in this conversation it can change even how they vote, and that's what I think going to make much more impact than try to talk to the politics and changing their mind.
Tejal, did you have anything to add on this point? Can't hear you.
Apologies. You can't? Can you hear me now?
Now we can hear you.
Yeah, all right. Yeah, no, so just briefly, I mean, I'm sorry if I contributed to the pessimism of the message, but I don't think it's there is a problem. In fact, in a lot of developing countries, you have far more ready uptake of the science. You have far less climate denial in developing countries, irrespective of capacities, perhaps in-house scientific capacities. There has been much more adoption very clearly of climate policies across regions in the developing world. In India, for example, you have agricultural departments, newer crop models coming up, and people working at regional and national level models, as well as actually working on the field of, trying to experiment. And this has changed remarkably in a very short span of time. Given that we work in academic time spans, we don't think, there's that much of an impact. And I agree that some of this cannot be measured in terms of publications and citations, and it shouldn't be. But unfortunately, we are also slaves to our professions, and that's what gets us tenure, for example. So you need to publish, and that's how we end up thinking about measuring our impact. But it is true that there has been significant shifts in the way in which people are thinking about the environment and climate, even in developing countries where you may not have as much of a footprint of the science as you do in developed countries. But I think the question, for example, of what constitutes a correct interpretation of science, where this entire focus on net zero in the developed countries is only a partial adoption of what the real science is. Nobody is talking about carbon budgets. In fact, the UK that spoke about carbon budgets, which is in fact the more complete measure of warming, went when it spoke about it in its earlier plans, but has now moved away from it in pursuit of net zero. So, you have sometimes even science feeding into, it's not just science providing evidence for policy, but policymakers telling scientists what they would like to hear, what it is convenient for them to hear. And I think this goes back to a little bit of the question that Jessica had about the pull and push, right? Is it always the case that you have scientists who are studying this with all the uncertainties involved, telling policymakers, this is what we have and this is what is happening? Or do you also have now a situation where policymakers know to a certain extent what the challenges are and what the issues are, but they also know that there's inertia in the system, and they're giving a message to the scientists that this much is convenient to us, so don't amplify the scientific message beyond that. And I am a little fearful that this is what is happening, that we are past the era where scientists were pushing for certain policies, and you have now scientists being dictated to in terms of what kind of science to produce. And that's becoming a bit of a problem. So we perhaps need to reverse the trend and push once again, go back to an era where we needed to push maybe plurality of approaches, welcome heterogeneity in terms of different approaches and perspectives in terms of how we do the modeling. Thank you.
So this has been go ahead.
I just want to add a maybe more optimistic point, but first I'll start with a story about Nordhaus's pessimistic very first version. If you read his biography that he put up for the Nobel Prize, the very first version of his very first climate model was rejected by all the economics journals, and he had to publish it in Science. But I think now I'll switch to more optimistic. I think within economics, there's been, an explosion of research on climate since I started working on this 10 years ago or something. I think the pull factor there might be partly just climate change. We can see it really happening. It's like it seems really important, and maybe it didn't seem before. Also, I think environmental economics is viewed as more methodologically interesting than maybe it was before. Maybe it was unfair to environmental economics, but we've seen like you can use all these modern tools from other IO or from micro and bring them here. But where I'm a little more pessimistic is whether you can convince economists to get actively involved in the policy world, because we don't reward that for tenure. And then working across this. So economists are maybe happy with their models, but then I find skepticism from sociologists or maybe climate scientists about what I'm doing. So to really have influence in the broader world, you kind of want to confront, you need to talk to other types of social scientists, and I think that's not rewarded so much.
So I'm getting the flag that we're at the end of our time, but I just wanted to flag that this particular interaction is actually an environmental, social feedback loop that we don't know that much about, and sort of proves the point of the panel. How do we tell better structured, informative stories about how to amplify exactly this loop between seeing the change, being more excited about it, having more conversations. This isn't humans and climate models and climate and human models, but this is the kind of conversation that we need to figure out how to represent, understand, and amplify. So we'll leave it on that optimistic note and that to-do list for all of us and head into the reception and dinner. The panel will be around, and Tejal, thank you so much for joining us. I hope you do get some sleep, and we'll be following up. If you have questions for Tejal, I think just let me know and we can convey them to Tejal and hopefully build something from this panel to amplify the interaction. Thank you.